Let's say you're just starting your hydroponic journey and you're excited to start growing. So you purchase your nutrient mix, follow the instructions carefully, and soon find yourself staring at a reservoir full of slightly tinted water, and you're left wondering, did I do it right? Or perhaps you confidently followed the instructions, put your plants in the system, and are now wondering how to care for these plants. In both situations, a key term that will improve your success as a hydroponic farmer is electrical conductivity, or EC for short. The reality is, as a home grower, you can't easily measure individual nutrients like nitrate, potassium, calcium, and magnesium without sending a water sample to a laboratory. That's both expensive and slow. So instead, we use a practical proxy. We measure how many dissolved ions are in the water, because that gives us an idea of the overall strength of our nutrient solution. Let's define the key word ion. An ion is an atom or molecule with an electrical charge. In water, many nutrients dissolve into ions, like nitrate, potassium, calcium, and magnesium. Plants take up nutrients primarily in these ionic forms. So when we talk about nutrient strength, we're really talking about the concentration of charged particles in the solution. More ions generally means a stronger solution. Fewer ions means a weaker solution. But here's the catch. EC tells you the total ion strength, not whether the mix is perfectly balanced. An EC meter is doing something surprisingly simple. It applies a tiny electrical signal through the water and measures how well the water conducts electricity. Pure water conducts electricity poorly, but the more dissolved ions you add, the better it conducts. So EC becomes a fast, repeatable way to track your solution strength. Most growers will see EC displayed as millisiemens per centimeter. For leafy greens, a typical target range is 1.2 to 1.6 millisiemens per centimeter. Some meters display microsiemens per centimeter, and the conversion is easy. There are 1,000 microsiemens in 1 millisiemen. So 1.2 to 1.6 millisiemens becomes 1,200 to 1,600 microsiemens. Same exact range, just move the decimal 3 places. Here's a big point of confusion. Many meters display total dissolved solids in parts per million. Those meters estimate total dissolved solids by measuring EC, then using a conversion factor of 500. If your EC was 1.2, then your parts per million would be 1.2 times 500, which would be 600 parts per million. However, there are 2 other conversion factors out there. Which factor your meter uses depends on where it was manufactured. This means 2 different meters can show 2 different parts per million numbers for the same water, just because the manufacturer chose a different conversion. US companies typically use the 500 or 650 factor. United Kingdom companies favor the 700 factor, and Australia may use any of these. So when literature specifies a parts per million, check both the factor it references and the one your meter uses to ensure they align. Sound complicated? I agree. And we don't need more complications in hydroponics. That's why I recommend you skip the TDS and parts per million reading and use EC directly. Most hydroponic guides and textbooks will reference EC, and it keeps your numbers consistent. Now that we've covered what EC is, let's look at the practical application. First, your nutrient bottle is usually a concentrate. It's a strong solution designed to be diluted. What your plants actually live in is referred to as the working solution. We combine our concentrated nutrients to water to form our working solution. How much of the concentrate depends on our desired EC. Here's something to keep in mind. An EC number is only useful if the nutrient formula is properly balanced. EC can tell you how strong, but it can't tell you whether the recipe is right. So follow your nutrient brand's mixing instructions. That way, your starting elemental balance is correct. Then, your EC measurement becomes meaningful for day-to-day control. EC isn't just a measure of the nutrients from your concentrate. It's a measure of every ion in the solution. That means we must consider our source water. EC of a working solution is going to equal the EC of your source water plus the EC from added nutrients. So you should always measure your source water first. As a general rule of thumb, source water EC should be below 0.3 millisiemens. If it's higher than that, you may already have significant dissolved minerals like calcium bicarbonates, sodium, or others, and you'll need to account for that baseline before you add nutrients, or you can accidentally push the nutrient concentration too high. How you manage EC depends on your system. In drain-to-waste systems, EC management is mostly about the initial mix, because any working solution not used by the plant is drained away and not reused. In recirculating systems like NFT and DWC, EC changes over time due to evaporation and plant uptake. Unfortunately, plants don't remove ions in perfect balance. They're like people. They have preferences and changing needs. When EC drops, the practical move is to add more properly mixed nutrient solution to bring EC back to your target range. While repeated additions ensures there is sufficient nutrients available, certain minerals can still build up over time. That's why a common best practice is to periodically refresh the solution. NFT reservoirs are usually easy to drain and refill. For larger DWC ponds, a small flow-through approach, adding fresh nutrient while venting older solution, can be more economical than full dumps. Remember, EC is your dashboard gauge for solution strength, but it works best when your recipe starts balanced and your source water baseline is understood. Keep it simple, track it consistently, and your plants will reward you.